that we need to know, right? So a graph consists of a finite number of vertices and nodes connected by edges. So you see those are blue dots there? Those are blue dots are what we call your nodes, right? Or sometimes we call them your vertices. And connecting them, we have edges. So let's take, for example, this node. This node has two edges connected next to it, right? On the other hand, this node here has 1, 2, 3, 4, 5. 5 nodes connected to it. Okay? Right? Now, based on the number of edges connected to the vertex, right? That gives you an idea of the degree. So for example, this one here has a degree of 1, 2. Has a degree of 2. So if they ask what's the degree of that node or that vertex, you're just looking for a number of edges connected. Right? Look at this one here. Let's call that R. What's the total number of nodes there? What's the degree of R? Anybody can answer. What's the degree of R them then? Three. Very good. 3. All right. So nice. So let's take a look at this one here. Let's look at this. You have 1, 2, 3, 4, 5. So you have 5 edges. So therefore, the degree of that, let's call that P. The degree of that is 5. Now, guess what? A loop is an edge with the same vertex at each end. It contacts the vertex twice. Right? Darian, can you draw on this node here? Sorry, this node here. On that node, can you draw a loop? Darian, can you draw a loop there, please? Yeah, draw a loop from another place. Nah, that's not a loop. So here's what a loop is, right? Let's look at the definition again. A loop is an edge with the same vertex on each end. Same vertex on each end. Try one more time. One more time. That's what I come up with. Same vertex on each end. So draw a loop on that same node I asked about.
I don't understand what you mean by the same vertex on each end.
Sorry, big man. I know you're a big man.
Oh gosh, I don't know. I don't understand what you mean by the same vertex on each end thing.
Oh, okay. All right. That's okay. That's happened. So this is the vertex we considering, right? That's the vertex we considering. So the edge has to start and finish at the same vertex. So if it starts here, it finishes right in. That is a loop. You okay with that?
Yes, sir.
Yeah, okay. So Jesse, can you tell me the new degree there? What do you think is the new degree there?
Before?
How much? Four?
Four? Yeah.
Four is that? Hold on
Yeah.
now, yeah. I don't know why I'm not getting on this. So my message in the group, what you all think? Why the volume so as no, it's a volume. TV volume on off. Talk again, anybody. Talk again.
It could be 4 edges, sir.
Alright, now something wrong there, we. I'm ready here. Alright, sum four. Now, here's the reason why, right? I'm gonna write in blue now. This is one, this is two, this is three. But the loop touching the vertex twice. One on this side, one on this side. So the loop contributes two to the degree. So the degree now is 5. Right? Make a note of that, please. The loop contributes two to the degree. Right? Few more quick definitions. Right? A walk is a sequence of edges on a graph in which the second vertex of each edge is the first of the next, right? So you're basically going from one to the next. A trial is a walk where no edge is repeated. So if you start somewhere you can finish, for example, no edge is repeated. So you can go here, then here, then here, then here, then here, right? You're not allowed at no point in time to come back here and then go back along that edge. You can't do that. Sorry. You can't do that, right? You can't go back along the same edge. Okay? That's called a trail. A trail is a walk with no edges repeated. A path now is a walk in which no edge and no vertex is repeated. Right? So a path is a path is a walk in which no edge. So you cannot go on more than one edge. So you can't repeat the edge. You cross the edge, you can't go back. Vertex, same thing. You can't go back to that vertex. Okay? So you need to know what is a walk, a trail, and a path. All right, so before we do CPA, let's do some questions now. Hold on, eh? Ooh, ooh. right? One definition I wanted to give you there, right? This is graph theory in a nutshell, right? I just make a note of what a circuit now. Then. A circuit is a path that begins and ends on the same vertex, right? Just add that to the definition. All right, let's try this now. What's the answer here? What is the degree of vertex T? Well, why this thing so bad? How much you all got? Message us, I'll make sure that we can attend to then. Yeah, let me message quick then. Correct, Jesse? Oh, no. Send the answers now. What's the degree of D? How much you all got? Correct. Right, Damian, correct. I got check numbers. A message, she done said 4. All right, nice, 4. So your degree is 4. Nice, nice and easy. Try this next one here. Good. Right. Try that in. Try the whole thing, huh? That good enough? Right. Check this out now. Last minute. right? So which vertices have a degree of 3, E looking like that, A looking like that. Oh, greater than 2. Oh, sorry. C looking like that. So we will say A, C, E, right? All three. Now they want all the paths. Remember, on a path, you can't repeat any vertex nor edge, right? So let's try the paths out. So you want all the possible paths from C to E. So we go in C, D, E. Then we go in C, A, E. Then we will go C, B, A, E. C, B, A, E. Of course, we can't leave out C to E, right? That's a straight path, right? C to E. Right? Did I leave out any? C, A, E, C, D, E, C, B, A, E. Any I left out? Jesse, I left out any or that good there? Good? All right, nice. So those are all the paths. Remember, you can't repeat any vertex nor travel along any edge more than once, right? Nice. There's one more I want to give you. Hold on, eh? Let's have to find back the year. Give me 1 second. Dario, llegará.
Yep.
Can I just hear now? I'm going to finish, right? So I'll do it. Any trails, right? Any 4 trails. Remember what a trail is, right? A trail has no edge repeated, right? But you can have a vertex repeated if you want. Ready? Right, so the degree of E I got to be 4, right? So that should be straightforward, right? That's 4, it have no loops, something. Identify trails. So remember, a trail just mustn't have the same edge. So I could go A, D, E. It can be closed, it doesn't matter, but you just go A, D, E. That's a trail. A, D, E, F, that's a trail. A, D, E, F, sorry, E, C, that's a trail. But I want to tell you what is also a trail, right? What you're saying. If we go A, E, if we go A, D, E, F, C, back to E, then back to A, that is also a trail, right? We are allowed to go through a vertex more than once. So if I do this, then here, then here, then here, then when I reach E, I go back up here, that could be a trail and a circuit. Right? Not really a circuit because I do E more than once, right? If I went BE, that would have been a circuit, right? But if I have E more than once, that is still a trail. A trail, I mean. That's still a trail, right? So your trails could go different places, right? ADE, you could go ADEF, ADFC, ADEC, right? ABC, right? Any of those options could be a trail starting with E. Right? And if you have one letter more than once, nothing wrong with that. Just make sure you don't go across the edge more than once. All right, nice. So that is your thing there. We did Hungarian already, right? We did linear programming, Boolean. Our last thing to do is critical path analysis. All right? So let me just try to explain what is critical path analysis, right? So watch this example here. So critical path analysis is like if you have a project to complete, right? Within your project, you're going to have all these stages. All right. So let's say you have to do your applied project. Number 1, you must have a topic. Number 2, you collect your data, right? You describe how you get your data and so on, right? So you have all these different things that you have to do. That's why give me 1 second. Right. So we have a list of all these things that we have to do. So yeah, so for example now, not every single thing in that list will be critical. Some things you might be able to leave out. So I'm just saying, right? You might be able to leave out the description if you have the data. Yeah, you'll lose marks, right? But critically, you can leave out how you get the data if you already have the data, because the data is what you're going to use to analyze, right? So you need the data to analyze, but you don't critically need to have the things in between, like the little discussion or those little things that are not important as yet, right? You don't have to go and describe fully how you get your data because you have it already. So what I'm trying to say is that critical path analysis only picks out the things that are critical. So you go in order, and then we apply a particular theory, a particular analysis that allows us to neglect the things that we don't need. All right. So let's say we have we have this activity here. Obviously, the activity has to start. But the problem is the only way you could do like for example, a chi-squared, you could only do your chi-squared in your project if you have your data. Right? You cannot start that until you have your data. So if your data take you 5 days to get, you have to wait 5 days before you start to analyze it. Okay? So I want you to understand what's going on here. We have to have an idea how long it takes for certain things to happen. So if you look at the table here, the table tells you that you have activities A, B, C, D, E, all the way to K. Right? But there is something special about A, B, and C. They don't need anybody. They have no predecessors. So A, B, and C can happen one time. So when you start, you could start at A, you could start at B, or you could start at C. Right? And of course, you have the days and how long. We'll do that afterwards, right? But I want you to notice something. The only way that D could happen, right? So the first thing we're trying to kind of sort of build here is we're trying to build this network. We want to know how everything happens. So I want you to notice something. T could only happen if we finish A. So from the start, we cannot start B until A finished. A finished now, A take 4 days, right? So after 4 days, we could start D. Now we look at what you say about E. Right? E could only happen after B. And B took about 7 days. So E happened in 7 days later. Look at F now. F could only happen if B happened. Nobody else, right? So now we could do a little thing here and we could say, well, here's what F could happen here 7 days later. Look at G. G could only happen if C happens. And C takes 3 days. So it gives you an idea of who happening and how long it takes before that person happens or that event happens. Look at H. H could only happen if E happens. Right? So after E is E takes you about 4 days, H will happen. Right? How long does it take for H to happen? It takes 7 and 4, 11 days for H to happen. Okay? I know. D must happen before I happens. So I is 3 days. Now look at J. J depends on F and G. So F and G must happen. Right? Before J happens. Right? F takes 7 days. And G takes 6 days. Okay? So I have a little question. Look at J happening, right? J could only happen when F and G finish. So let's say G finish at 6 days. Then here's what happening. J still can happen. J needs to wait on 7 days for F to happen, for F to finish. So what it's saying is that F is critical for J to finish, right? So I want you to bear those things in mind, right? That's the only way that J can happen. F had to finish. F is 7 days. Right? And lastly, K. H and I. For K to happen. Right? I is I took how much days? I took 3 days, H took 10 days. Right? K took 2 days, J took 4 days. And that will take us to finish. Right? So that gives us an idea of the network. Now, the trick for us now is to try to figure out, okay, what is the critical path? So why is it, so why am I not seeing this one? Yes, now, E to what? Oh, somebody send that. So why is E to H4? Why is E to H4? Oh, yeah, so how long? E to H. Oh, because E took 4 days. And H is dependent on E. Right? So the number I'm showing you there, I'm going to show you our next way to write it, right? But this just showing you the part. So the numbers you're seeing is how long before E happens. So before F happens, it takes 7 days before F happens from B. All right? So head up critical path analysis, copy this table down, and then we'll use this as our first example. And then I want you to construct this activity network. This is not the final way we will do it, eh? This is just the way we will start it for now, right? But I just want you to start up like this for now. Draw it for me and tell me when you finish, please. Then we'll go into the other important thing. It's how you determine the critical path. All right, I'm gonna finish it. Finish? Okay, let's go. All right, let's go. Good. So the problem now is how does this help us get the critical path? Right, so we'll come back to this just now. Right, there are many different ways to do it all, yeah? I am just giving you one of the ways, right? Right, so I know you all may have done something different in school and thing, but you have different ways that you could do this because plenty different disciplines just use it, like businesses use this a lot, science, right? Different people use it, so. Hold on, just trying to find the right. So here's what we have. So critical path analysis, the circle that represents, so instead of drawing like the letter on the outside, numbers on the lines, we want to make it clear. So a circle that represents a point in time where an activity is started and finished. So a node can be split up like this. Left-hand circle represents the unique node activity number. The network diagram draws these in order. So we cannot just put E and thing in it, right? You want to break it up a little bit more. So what you could do is you could write the letter A, for example, in it. And then top right-hand corner, this is important, right? The top right-hand corner, right? Shows the earliest start time, EST, right? So EST is the earliest start time. So you have a little node here, you have your earliest start time, and then you have your latest finish time. So earliest start time, that an activity can commence based on the completion of the previous activity. Okay, and the bottom right section shows the latest finish time by which the previous activity must be completed. Okay, so basically to get one of them, you go in from start to finish. To get the next one, you go from finish to to start. And then you take a look at the numbers. Numbers are the same, means that that particular event is critical. Okay? Let's just take a look at this quickly, and then we will try it, right? We'll go back to our own. So an activity is something that takes time. An activity is shown on the network as a line linking the nodes, right? A description of the activity or a letter representing the activity is usually above the relevant line, right? So sometimes you just put like A or B and you put a number. The length of time it takes to complete the activity shown as a number. The length of time it takes to complete an activity shown as a number of relevant units under the activity line. Okay, so that's talking about when you look at the table, how it will look, right? Let us see if we could go back to ours and do it, right? Hold on, yeah. I'm just looking for, I want to do a full example on the board for you. And then I want you to do the one that I have there, right? Give me 1 second. Right? I am going to do this one, and I already helped you with the last one. I want you to replicate it, right? So this is the activity. This is before it happens, right? So this is like a predecessor. Right? And this is the duration in days. Right? Nothing here. This is A, this is A, this is B, this is B, this is B and C, this is D and E, this is E and F, and this is F. So the duration will be 2, 3, 1, 2, 4, 1, 3, 5, 2. Right? I'm going to use this method here. I don't know. I kind of like this box a little bit more. Right? This is the activity. This is the earliest start time, latest finish. This is the duration. I like this one because it's showing every single thing one time. Right? Earliest finish, latest finish, latest start. Right, give me 1 second, right? We're gonna fill this one out. So use this one, right? I know that's the one I have in the note, but I like this version a little bit more. Right? The reason is that this shows you everything. right? The reason I know how it lines up is because they do the critical, they do the activity already, like what I did for you a little while ago there. Again, if you have your own method, no problem, right? Right. So let's start. So you recognize A has no predecessor, so A goes here and 2 goes here because it takes 2 days, right? Next, A, B is and C is dependent on A. So let's put B here, C here, right? And B takes 3 days. So again, from here, right? B took 3 days, C took 1 day. Next was dependent on B, D, and D took, yeah, D took 2 days, right? What is dependent on B again? E. E took 4 days, right? F is dependent on B and C, right? F is dependent on B and C. F took 1 day. F took 1 day, right? And then G is dependent on D and E. G is dependent on D and E, right? G dependent on D and E, and G took 3 days. And then H is dependent on E and F, and H took 5 days. And I is just dependent on M. Right? I took, did I make a mistake, boy? Yeah, I write the wrong thing. 1353. Took 3 days. Right? So let's start. So the earliest start time for A, of course, is 0 days, right? Because nothing dependent on E. Okay? So now, what's the earliest start time for B? The earliest start time for B is 2 days. The earliest start time for C, oh, sorry. Earliest start time for C is 2 days. That's okay? Right, Olia, I don't want to block all this. Just write down this somewhere now. You don't have to do that as yet, but just write down this somewhere. I don't want to block you. Right? I don't want to block you. So just write on the table, example 2 if you want. Write on the table, and then I want to go through that with you. Come on, you finish, right? Finish. Diane, you're done. Finish. Write the table. Diane, I can go ahead.
Yes, sir.
All right, nice. So let's go. Of course, what I'll leave out start, and I'll leave out finish. All right, let's go. So we could start here at 0 days. We know that for sure. 0 days, right? It'll take us 0 days. So the earliest time we could start A is 0 days. Now, what's the earliest we could finish A? To get that here, earliest finish, 0 plus 2 is 2. So it gives us an idea the earliest A could finish. Now, B is dependent on A. So the earliest start for B is when A finished, 2 days, right? And the earliest start for C is 2 days. Now, what is the earliest finish for B? B takes 3 days, 2 plus 3 is 5. What's the earliest finish for C? 2 plus 1 is 3. All right, now let's come up here now. Let's go to D. D, what's the earliest time D could start? B had to be done, right? So that will be 5 days. That's the earliest D could start. 5 plus 2, 7. That's the earliest D could finish. Let's go to E now. E is only dependent on B. So the earliest that E could start is 5 days. 5 plus 4 is 9. That's the earliest it could finish. F now. F is dependent on B and C. But after 3 days, right? B not finished. So F is dependent on B as well. So it means that the earliest that F could start, is 5 days. Not 3, yeah? Because if you put 3 here, B not finish. So the earliest time that F could finish is 5 days. 5 plus 1 is 6. So the earliest that F could finish is 6 days. Right? So technically, in short, whenever you have two choices, you take the larger number. Okay? Let's come here now. G is dependent on D and E. But after 7 days, G can't start, because E not finished. So I had to go with 9. 9 plus 3 is 12. Here, 9 and 6 days. So it basically means that H could only start after 9 days. 9 and 5 is 14. Right? I is dependent on F alone. F finishes at 6 days. 6 plus 3 is 9. Right? How long does it take to finish? All of these going to finish. Right? 14 days. Right? Because it can't start at 9 days. It can't finish at 12 days, no 9 days. It has to wait until each finish before I could say finish. So that's 14 days. Anybody confused, Thelma? Anybody confused with the forward action? We're going to do the reverse action now. Anybody confused? Once you understand one, you can figure out all, right? Kaden, are you okay? Damian, are you okay? Kaden, you okay there? Dario, are you good? Okay. So now we're going in reverse. We want to understand latest finish and latest start. Okay? Latest finish and latest start. So the best way to do it is to go in reverse. Right? So let's check it out. So of course here could be 14, right? Because we can't do anything else to finish. Must be 14 days. So what is the latest we could finish? What is the latest we could finish I? Right? And I want you to think of the logic behind it, right? Think of the logic behind it. The latest I could finish I is, if the finish time is 14 days, the latest I could finish I is 14. Okay? Because if I have 14 days to finish, when I reach 9, I still have a little 6 more to play with. I mean, sorry, 5 more to play with. So because you have play time here, this thing not critical. Right? Not critical at all, because you have play time. Now, if I finish in at, the latest I could finish is 14, then the latest I could start is 14 minus 3 is 11. Right? I could start that at 11 days because you know why? It's only taking me 3 days to finish that job. So I could start at 11, I could rock back, start at 11 and finish that in 3 days. And then I finish at the normal time that the boss want me to finish in 14 days. Okay? So what you could recognize already is that I, not that critical. I could play around a few days with I. Right? So it means I not critical. But look at H. The latest I could finish 8 is 14. 14 minus 5 is 9. So here what that means? It means that I must, the latest I could start I is 9 days. Sorry, H is 9 days. And I have to finish in 5 days. So it means that H is a critical teller. Must be there. Critical. No playtime at all. Here, 14, right? 14 minus 3 is 11. So I have some time to play around here as well. Okay? I have some time to play around there. Now, what is the latest that this could start? So you see why I'm going this way to figure out latest, right? You're going backwards to figure out latest. All right? So I want you now to focus on, let's focus on the others now. Let's focus on D, E, and F. All right? So let's start with F. Right? F is a little bit tricky because the latest I could start F has to be dependent on these two numbers here, 9 and 11. So what I'm seeing here is that the latest I could finish is 9. Right? The latest that I could finish there is 9 because if I choose 11 days, 9 minus 1 is 8. Right? If I choose now, here's what. If I choose here, right? Think about this, huh? If I choose to finish this job, remember, latest finish. If I choose to finish this job at 11, I'm in real problems. Because if I finish this job at 11 days, what will happen to H? Right? If I finish it on 11 days, 11 and 5 is 16. Real problems there. H can't finish on time. So the latest I could finish F is mid 90. So I'm taking the smaller number. But what I want you to understand is why. Why is it doing that? Okay? The reason it's choosing the smaller number is because if I put 11 here as my latest start, latest finish, then I'm in problems here. H can't finish on time. That makes sense, Jesse? That makes sense? I don't want to also just understand, well, when I'm going backwards, I take the smaller. When I'm going forward, I take the bigger. Yes, I want you to know that, but I want you to understand why. Okay, Jesse? You okay with that, right? Let's go here again. So this is 9 and 11. So I have to take 9, right? Because of car finish on the 11, right? So 9, yeah, take the smaller one, 9 here. 9 minus 5 is 4. These two are the same, no wiggle time. So you know that is no plating there, right? 11. So I could finish this on the 11 and still be good because this have 3 to finish, right? 11 minus 2 is 9. Right? What am I doing here now? Right. Who to choose for? Let me go here now. Let me go here. Here I have 8, 5, and 9. I have to choose 5, right? I have to choose the smaller one. And I'll explain why, right? 5 minus 3 is 2. Here, I only have one choice. 8 minus 1 is 7. Right? Of course, I had to choose the smaller one. 2 minus 2 is 0. Right? I can't choose 7 here because 7 gonna mess up the whole system. You understand? If you mess up the whole system, you're in trouble. Right? And then 2 minus 0 is 0. So what does that mean? What is the critical part? The critical part basically is when the earliest finish and the latest finish, same value, when both of them equal. So who is that? A, B, E, H. That's the critical part. I don't need him because he play now. I have time to play here, I have time to play here, I have time to play here, and I have time to play there. So it means that that is your critical part. So I want you to copy it down, and I want you to try to figure out now. I want you to try to figure out now what to do. Anybody confused with this? Right? So remember, going this way, we go 1, 2, 3. Going the next way, we go this way. Right? So we figure out earliest to the, we figure out earliest whenever you're going this way, and note that we take the largest value, and I explain why. And then when we go in this way, we figure out the latest, and we take the smallest value. Okay? So copy this down. If anybody could, I'll take a little pick and save it, right? I like this particular example. Okay? Copy it down, and you don't have much time to go homework. Do what you want to give you, right? So we already know the network. We already know where everything should go. Just connect it up. I like this a little bit more because you don't have to do no calculations in your head like the one I gave you in the handout. I like this one a little bit more because you're seeing everything, right? So you know you start here, you add to get here, and then you minus to get here. Okay? I just like to put these things here just to help you remember. EF is ES plus duration, and LS is LF minus duration. I will change the note because I want to have this in the note instead. I don't like that they do it. Alright, so when you're all done, that is it. Alright, that's it there. You can wrap up. Where does find the things that you saved, boy?
Electricity, zero PCB, electricity, zero electricity, zero PCB.
Right, that's it. You could copy it down and wrap up, right?
Zero electricity, zero PCB, electricity, zero electricity,
Right, so the quick. Come here.